So I want to end this module by talking a little bit about notation, which I know is everybody's favorite topic, but it's important for us. Okay, so one of the things that we've been doing is it's kind of strange, but we've been using a formal notation informally, right? And here's what I mean by that. We're using a formal notation. It has ands and ors and implies, and with parentheses, and we've been very careful. But I haven't really told you what the rules are about the notation at all. So, for example, here is something which is a valid statement, right? And we use our intuition to tell us that it's valid. X and Y or Z, that seems true. But what's this? X and or Z? That doesn't make any sense, right? So why is that? And like I said, I've been counting on you to just recognize that it isn't valid, right? So let's fix that, okay? So I'm going to tell you what an expression is. I'm going to give you the rules. And the rules are going to start like this. True and false are valid Boolean formulas, okay? So if you want a valid Boolean formula, you can write down true, you can write down false, either which is fine, okay? It can also be a Boolean variable, right? That is also a valid Boolean formula. And what does a Boolean variable looks like? Looks like a lowercase letter, okay? Maybe it's subscripted, like for example, y, so 12, 1, 2, okay? Maybe it's a lowercase word, like row. I'm also going to allow that, right? So those are valid. If you have a proposition, which is a Boolean formula, a variable, or if you have the constants true and false, then I'm going to say that is an atomic Boolean formula, okay? And the reason that I'm calling it atomic is because of this. I'm going to combine those now. So suppose that I have two valid Boolean formulas, alpha and beta, okay? Then all of these are also valid, okay? So alpha or beta with parentheses around it is valid. Notice that if there's no parentheses, it's not valid, right? So I need the parentheses. As soon as I have a connective like or, I'm going to need to put a parentheses around it. And implies, all of those are okay, right? So I take two different Boolean formulas, I put and between them, I put parentheses outside of them. That's a new valid Boolean formula. Another one that I can build is just ignore the second one and just take the first one, put a not in front of it, and then put parentheses around it. So those we're going to say are legal. Okay? A little bit of fine print, right? The lawyers are going to get involved. Those are the only things that are valid Boolean formulas. If I didn't add that fine print, then you can come in and say, yeah, I agree that all those are valid, but you never said anything about X and or implies Y, right? You didn't say that that was valid, but you didn't say that it wasn't valid either. So this just makes it clear. If it doesn't say that it's valid, then it's not, okay? Okay, so let's look at some Boolean formulas. True. Yes, that's actually a Boolean formula. Why? Because it's one of the constants, right? X. Yes, that's actually true. Not true, I'm sorry. That's actually valid because it's one of the propositional variables, right? Okay, how about true or X? Notice the parentheses outside it. And the answer is yes, that's valid because we know that alpha is a valid formula, alpha is true, and beta is a valid formula, beta is X. Then so is parentheses alpha or beta, close parentheses, right? How about parentheses false and X and true? Well, let's see. We know that this is valid. This expression here we know is valid. Think of it as beta. Now that I have alpha and beta, right, is valid. So yes. Okay. For the same reason, so is this one. I have two different valid formulas. Again, notice they're fully parenthesized. I put a connective in between them. I put parentheses outside of it. That's also valid. And how about this one? I have a valid formula, not in front, parentheses outside. Yes, that's also valid. So yeah, all of those are valid, right? And the thing that works here is that I can use those rules to tell me what they are. Okay. Now, I pointed this out before, and I'm going to point it out again, and some of you may be saddened by this, but it's just a fact of life. Different books use different notation. Different professors use different notation. So here is an alternative notation that I've actually seen in some books, okay? Implication is written as kind of a superset notation, okay? Negation is written by having a horizontal bar over the expression, and we're using ands and ors in a more computery notation than the logical notation that we've been using in this class. Okay. Here's another way of writing that. So we have x, and actually the letters A and D for and. Notice that everything is parenthesized there. There's an or. Ooh, that's not parenthesized. Okay, we can actually get away with that because it's unary is the only unary symbol. So we could do that, and then that implies z. So that's another syntax that you might see in some books. Generally speaking, I think it doesn't matter what syntax you use. You simply have to be able to swap to whatever syntax your current textbook has. Okay. All right, we did predicates. Can we also do? We did propositions. Let's try to do predicates. So we'll do it again. True and false are valid predicate formulas. Now I have to talk about other constants, right? Those are logical constants, and logical constants are valid predicate formulas, okay? But non-logical constants are not. So we have some other constants, for example, numbers. We might have strings, we might have, it depends on what domain, right? So if you need strings, then there's a constant, cat. If you need colors, then there's a constant for colors. The point is, whatever domain you need some way of writing down the elements in that domain. Those are not predicate formulas, right? Because a number is not true or false. So those are just numbers, generally speaking. We do have variables. I like to have variables lowercase. I don't always follow that rule. But we're going to say that they're lowercase and possibly subscripted, like x sub 1, y sub 1, rho sub 3, and so on. Again, variables are not valid predicate formulas because what's a variable stand for? A number, right? Not a Boolean, true or false. Okay. So now that we have variables and constants for our numbers, we can talk about what a predicate is, right? And a predicate is called an n-ary predicate if it expects n arguments. So it consists of a name, followed by a parentheses, followed by however many arguments you need, followed by a close parentheses, okay? Now, each argument could either be a constant or it could be a variable, right? But it can't be a predicate, okay? Because predicates, are either true or false. They're not numbers, so we can't do that, okay? Together, when you have a predicate that has a whole bunch of parameters, right? We call that a atomic predicate formula, right? And again, it's atomic because you can't split it up. It's indivisible, right? So our next step is to show how we can take these and combine them, right? So let's say that I have alpha and beta, which are now valid predicate formulas, and that x is one of the variables. So what we have is that here are some more predicate formulas, right? So these ones you'll recognize, right? That's just simply using the logical connectives, like we did before, and saying either alpha, logical connective beta, and then parentheses, or parentheses not alpha, close parentheses, right? Those are just the same rules that we use for propositional calculus. And then we have two more. We have parentheses, quantifier something, quantifier variable, and then a formula. And that's also legal, okay? Now, again, these are the only legal predicate formulas. So yes, I can actually give you a set of rules that describe what it means to be a valid formula, and that can be useful. Okay. I mentioned that there's different choices of notation. Here's another choice. Okay. So we're going to have ACL2. ACL2 is a computer language that we're going to learn in the next module, and the reason that we're using it is because it's not just a language. It comes bundled with an automated theorem prover that we can use to prove things about our programs. So we want to learn its syntax, and its syntax is quirky, okay? But it's just syntax. We got to get used to it. So here are the rules. It has constants for true and false, but because of historical reasons, they're not true and false. They're T for true and nil for false. Why? Historical, okay? It has other constants. It has numbers like 3. It has numbers like 1/2. That's not a division. That's considered a number, okay? This one's kind of weird. It has what are known as symbols, okay? And a symbol is basically any kind of combination of letters, but you have to quote it. And the way that you quote it is by putting a single quote in front of it, okay? It also has strings, right? and strings are double quoted. We're not going to ever use strings, okay? But we will probably use symbols quite a bit, okay? So all those constants are kind of valid ACL2 formulas. Mind you, I didn't say predicates. I just said formulas, okay? So what are variables? Variables are lowercase, right? And they can actually have really crazy symbols in front of them. For instance, y-12 is considered a single variable. That's not y minus 12. That is y-12. It is a name. That's because hyphens are letters, okay? All right. You're going to see that, that there is no subtraction that looks like y minus 12. That's actually not a valid formula. Okay, we also have n-ary predicates, right? And the way they work is they have a name and n arguments. But instead of using commas, we use spaces to separate them. And you have to put parentheses around them, right? So, for example, parentheses odd x. The way to read that is x is odd, right? So odd is the name of the predicate and x is the argument. We've been using odd parentheses x, okay? That may be more familiar, but in ACL2, you simply take that and you move it inside the parentheses. Sorry, it's just syntax, okay? Here's another one. Right triangle 3, 4, 5. That's the property of the numbers 3, 4, and 5, which actually make up the sides of a right triangle, okay? Now, what can the arguments be? The arguments can be constants or variables. And predicates themselves are actually valid ACL2 formulas, okay? Now, later, when we get deeper into ACL2, we'll make one more step. And we'll think of predicates not really as special things that are at the top and everything else is kind of separate. We'll simply think of predicates as functions, okay? And they're functions that happen to return booleans, true or false, whereas some other functions, like plus, take two arguments and return another number, right? So that's the only difference that ACL2 sees when it looks at predicates. ACL2 thinks that everything is a function. Predicates just happen to be Boolean functions. Okay, so how do we combine ACL2 formulas? We've seen the atomic formulas, and we're going to use the same sort of rules. Suppose that alpha and beta are valid formulas in ACL2, then or alpha beta is a valid formula. And notice the syntax is parentheses or and then alpha beta. Again, that's the same formula we use for predicates. It's actually the same kind of syntax we use for functions. So you see that they're all the same to ACL2. There's parentheses, a function, and then the arguments that it applies to it. In this case, our function, quote unquote, is or, which is a logical connective. Same goes for and, alpha beta, implies alpha beta, and not alpha, okay? Again, we're going to have the legal ease that these are the only valid formulas, okay? This is it. And one nice thing about the ACL2 syntax is that we'll be able to relax things a little bit in the future. So for example, if you have alpha, beta, gamma, delta, and you're taking the or of all those, instead of having to say alpha or beta or gamma or delta and then parenthesize that, you can simply say or and then list them, okay? It's unambiguous. It knows what you mean, so we can get away with it. Okay, so let's actually have some examples of these. How about or and x, y, y? That's a friend, right? That's the absorption rule. And notice what's happening here, right? Or alpha, beta. Alpha just happens to be a kind of an expression in its own right, okay? So there's alpha, there's beta, okay? And so that's why it's a valid ACL2 syntax, okay? Here's another example. Equal or alpha y. This is the equal, right? And so normally I would have said this equals y, but that's not the ACL2 way, right? The ACL2 way is that you always put the function first and then the arguments. The function in our case is equal, right? And remember, ACL2's perspective is that predicates are just functions that return booleans. Logical connectives are just functions that take in booleans and return booleans and so on, right? So equal is one of our predicates.